Okay, I'm going to do a couple graphing problems with the characteristics for radicals. Um, I seen your uploads and I spot checked your homework, but I did not go through every single graph because that would be way too tedious. So I want to do a couple of the problems from the homework, give you some examples, and then be prepared. We'll have a quiz next week. I don't know if it'll be Monday or Tuesday. I'll figure that out this weekend and we'll let you know. So again, this is the homework that I asked you to turn in on Wednesday. So I've already graphed my parent function. This one's Becky, my square root. So I start with 0, 0, 1, 1, 4, 2, and 9, 3. Looking at my values in here, this is going to represent a vertical stretch by a factor of 2. When I do anything vertically, it affects the y values. So all of my y values will be multiplied by 2. I have to graph this first. So whenever you have a stretch, a shrink, or a reflection, you've got to graph that first and then do your movement. So I'm going to take my original graph and I'm just going to modify my y values. So my 0, 0 stays. Then I go to 1, 2. Sorry, yep, 1, 2, 4, 4. And then my 9 is at 6. So I can see that my y values are higher. It has more of a curve. And then I'm going to move it. So this moves to the right 2, and this one moves up 3. So I'm going to take all of my values on my points and move them to the right 2 and up 3. I'm going to go ahead and redraw my table. So going to the right 2, this would be 2, 3, 6, and 11. Moving them to the right 2, and then I'm going to take my new y values, and I'm going to go up 3. So this would be at 3, 5, 7, and 9. My graph won't quite fit on the graph, but that's okay. I'll fit what I can. So I have a 0.23. Let me put some pen. And I have 3, 5, 6, 7, and 11, 9. So 1, 2, 1, 2, 3, somewhere up here. I'm going to kind of go off of my graph a little bit. So it has the same curve as this one. Definitely more curved than my original. I'm going to fill in my information now that I have finished my graph. So my starting point is at 2, 3. My domain is from this point and everything to the right. So that's going from 2 to positive infinity. My range is going from this point and everything higher. So that's going to go from 3 to positive infinity. I do have an absolute minimum value because everything is going to be higher than that point, and that point is going to be at 2, 3. My entire graph, starting from the left and going to the right, is increasing. So it's increasing all of my domain values. So your increase and decrease interval is always going to be your domain for these problems. Then for my end behavior, I'm going to look to the left and I'm going to look to the right. On the left, I don't go to negative infinity. The farthest to the left I go is the x value 2, and it has the y value 3. I think I missed that point. My apologies. My point should be there. This is why you don't do math in pen. So 2, 3 is the farthest point on the left. On the right, my arrow is going to as far right as it can possibly go, which is positive infinity, and it's going up, which is also positive infinity. And behavior will depend on the graph that I have. Every square root graph will have one set for the end behavior. That's that starting point. And the other ones will deal with infinities. It could be positive infinity or negative infinity. It just depends on what the graph looks like. Right, I'm going to look at problem number 3. I've gone ahead and put Jim in, my parent function, with -8, -1, 0, 1, and 8 for my x values. And then I'm going to do my transformations. So this is going to reflect across the x-axis, which is going to make all of my y values change their signs. So let me go ahead and change their signs. This is going to reflect across the y-axis from this side to this side. from here to here. So it's going to affect all of my x values. They are also going to change signs. So let me go ahead and change my signs. I do have some movement to do, but I'm going to do my reflecting first. So I have positive 8, positive 2, 1, 1, 0, 0, negative 1, negative 1, and negative 8, negative 2. When I reflected across the x and the y-axis, this graph stayed the same. All right, then I'm going to do my movement. This is going to move to the right 1 and up 2. So I'm going to take all of my x values and move them to the right 1 by adding 1. And then take all my y values and move them up 2. So I'm going to add 2. So this time, instead of using my points, I'm just going to take the points that are on here. I'm going to move them to the right 1 and up 2. So my graph has the same shape. Oops, went too far. It's just been moved up 1. So again, I flexed across the x-axis and the y-axis, but it ended up having the same image. For this graph, for all cube root functions, there is no starting point. There is also no absolute max or absolute min. My domain, it goes left and right for forever. So that's going to be negative infinity to positive infinity. It's also going up and down forever. It's going slowly, but it is going up and down. So my range, negative infinity to positive infinity. So my entire domain will be my interval of increase and decrease. And for this one, it is increasing. So for my end behavior, every time we have a cube root function, I can go all the way to the left and all the way to the right. So on the left, my arrow is pointing down. That's negative infinity. On the right, my arrow is pointing up. That's positive infinity. It's going up and down, but it's going slowly. Okay, and then I would like to look at these two problems. My printer kind of gave out on that second page in the printing. So it's tough to read. But I'm going to start with just a generic equation. So for the first one, I'm going to start with the square root of x. And then for the second one, I'm going to start with the cube root of x. It's not specified, so it really doesn't matter which one you deal with. So I like to put this all out there, then I can fill in my information that I'm looking for. So if I compress vertically, that affects the y value, so it needs to be outside of the function. It's a compression or a shrink, so that's going to be a multiplier. So my 2/3 is going on the outside. Everything on the outside has a normal value. Then we're reflecting across the x-axis. So that's going from here to here, which is affecting the y values. So that's going to be on the outside of my radical. So I'm just going to put a negative in front of my 2/3. Then I'm going to move left 31. So that's affecting my horizontal value going to the left 31. So it's going to go underneath my radical. And anything that I put underneath the radical, I have to put it in the opposite form. So instead of a minus 31, I'm going to put a plus 31 with my x. And then it's going down 24. That affects the y values going down. So it's going to go outside of my radical, and I'm going to put it as it looks. So it's down, so it's going to be a negative 24. I don't really need the parentheses since I didn't have a b value in here. You can have them, you cannot have them. It really doesn't make that much of a difference. For my number 10, I'm going to start off with my stuff. All right, so we're going to compress horizontally by 1/2. If I compress horizontally, I squish it this way. So it's going to affect my x values. So it's going to go underneath my radical, but my b value is not 1/2. It's the reciprocal, which is 2. So if I add or subtract underneath the radical, then I change the sign. So left is adding, right is subtracting. When I have a compression or a stretch, I need to do the reciprocal of that value, the specific value. All right, then we're going to reflect across the x-axis. Again, that's affecting the y value, so that's going to go on the outside of my radical. I'm going to go to the right 29. That's in my horizontal distance. So I'm going to change my sign, and then up 87, that is normal. Please make sure that when you have the number added or subtracted at the end, that your radical stops. If you include it underneath the radical, you have now affected the value going to the right. It is also going to the left. So make sure that your radical stops before you have your addition or subtraction. If you have specific questions, please send me a message. I'm here. I'll respond to emails or remind text messages, but please, please, please ask me questions.